Let's understand listening or recording of a sound frequency. Now we are going to study how an observer detects the frequency of a sound which is approaching him. Say if there is a source of sonic oscillations, or you can say there is a sound source which is at rest, and at some distance from the source there is an observer, and this observer is also at rest. When the source started producing sound, say the frequency of sound is given as n0 hertz. That means in 1 second it is producing n0 oscillations. And say the sound speed is given to us, which is equal to c. That means as soon as it starts oscillating, the sound starts propagating in the medium towards observer. And we know corresponding to one oscillation, the wave travels a distance which we term as wavelength. So there is the wavelength of wave which is lambda naught, and here wavelength can be written as c by n naught. It is the distance traveled by the wave in one oscillation. So if continuously the source is producing oscillations, the wavelengths are continuously produced one after another, and continuously the wave is traveling towards the observer, and observer is receiving these oscillations. As the sound is approaching to the observer at a speed c, we can say in 1 second, as the wave travels c meter distance, so we can consider a length which is c meter from the observer. The portion of wave which is located here, we can say this portion will be able to reach observer in 1 second, because in 1 second the wave is traveling c meter length. That means in this particular length of c meter, whichever be the number of oscillations that will be observed by the observer or will be detected by the observer, because one oscillation is equivalent to one wavelength. So if we wish to find out the number of oscillations heard by the observer, that is equal to number of wavelength received by the observer in 1 second. That is number of wavelengths received by the observer within c meter of length, because in 1 second c meter is covered by the wave. So we can say in 1 second number of oscillations detected by observer is equal to number of waves or wavelengths in c meter length. I hope it is clear to all of you. Now in this situation, this number of oscillations detected by observer in 1 second can be written as apparent frequency heard by observer, and this can be written as n apparent, which is equal to number of wavelengths in c meter. One wave is of length lambda naught. So we can say in c meter length total number of waves can be written as c by lambda naught, and c by lambda naught is equals to n naught. That means we can say the apparent frequency heard by observer is equal to actual frequency of source if both source and observer are at rest. Now if either of these starts moving, the parameter will change. How it will change, let's discuss in coming section. But this is the way you should understand very carefully how the observer detects, or if a detector is placed here, how it will record the number of oscillations in 1 second. Actually it will only count the number of wavelengths received in 1 second, because one wavelength is corresponding to one oscillation.